When we look up at the night sky, we're not just seeing stars, we're looking at possibilities. Possibilities of other worlds, other civilizations, and maybe, just maybe, other minds asking the same questions we are. Technosignatures are the traces, the cosmic fingerprints that a technologically advanced civilization might leave behind. They are not the same as biosignatures, which suggest the presence of life. Technosignatures point to intelligent life, civilizations that build, modify, and interact with their environment on a scale that nature alone does not. But what exactly could these signatures be? Radio signals are the most famous candidate. Since the 1960s, we've been listening to the stars through projects like SETI, searching for narrowband radio signals that wouldn't occur naturally, something like a beacon deliberately or accidentally transmitted into the cosmos. But technosignatures go far beyond just radio waves. They could include things like laser emissions, powerful and focused beams of light, possibly used for communication or propulsion. Megastructures, like Dyson spheres or swarms, hypothetical constructs that could surround a star to harvest its energy. Atmospheric pollutants, chemicals in a planet's atmosphere that don't occur naturally, like industrial gases or artificial compounds. Night-side illumination, cities or planetary surfaces lit up in a way that only technology could produce. Unusual heat patterns, waste heat from massive infrastructure or computation, detectable in the infrared spectrum. In essence, a technosignature is anything that suggests someone intelligent was here, or still is. The exciting part? We now have the instruments and computing power to begin searching in earnest. And the search is no longer just science fiction. It's a frontier of modern astronomy. So the question is no longer if we can look, but where, how, and what exactly we're looking for. Our journey to find intelligent life in the cosmos didn't begin with high-tech computers or interstellar probes. It began with a simple question. Are we alone? This question has echoed through centuries of human curiosity, but the scientific search for alien signals truly began in the mid-20th century. In 1960, American astronomer Frank Drake conducted the first modern attempt to detect extraterrestrial signals with a project called Project Ozma. Using the Green Bank Observatory in West Virginia, Drake pointed a radio telescope at two nearby sun-like stars, Tau Ceti and Epsilon Eridani, listening for any artificial radio signals. The results? Silence. But the attempt sparked a movement. By the 1970s, the idea of sending signals to potential alien civilizations took hold. One of the most famous efforts was the Arecibo message of 1974, a radio transmission beamed into space from the Arecibo Observatory in Puerto Rico. The message was brief, just 1,679 bits long, but encoded information about humanity, our DNA, our solar system, and even a stick figure representing a human. Then came one of the most famous moments in SETI, Search for Extraterrestrial Intelligence history, the WOW signal. In 1977, astronomer Jerry Amon at Ohio State University noticed a strong, narrowband radio signal that lasted 72 seconds, far stronger than anything naturally produced. He circled the signal on a printout and wrote "WOW" in the margin. The signal has never been detected again. Was it alien or just an unexplained anomaly? We still don't know. Meanwhile, humans weren't just listening, we were also sending. The Voyager Golden Records, launched aboard the Voyager 1 and 2 spacecraft in 1977, are perhaps the most ambitious message in a bottle ever sent. Each gold-plated record contains images, music, greetings in 55 languages, and scientific diagrams, meant for any intelligent beings who might someday find the probes drifting through interstellar space. In recent decades, SETI has become more advanced and more global. Arrays like the Allen Telescope Array scan huge portions of the sky, and projects like Breakthrough Listen collect petabytes of data, searching for narrowband signals that might stand out from the cosmic background noise. And yet, despite decades of listening, nothing conclusive. But maybe silence is not a sign of absence. Maybe we're just not listening the right way, or at the right time. Maybe the universe speaks in a language we haven't yet learned to understand. When we talk about searching for intelligent life in the galaxy, It's not just about pointing our telescopes at the stars and hoping to see a spaceship. The real strategy is to look for indirect signs, technosignatures, that indicate an advanced civilization might exist, or once existed. But what exactly are these technosignatures, and how can we recognize them? One of the most straightforward technosignatures is radio signals. For decades, scientists have scanned the skies for narrow bandwidth radio transmissions, the kind that nature doesn't usually produce. These types of signals stand out because they're too precise and organized to be random. Projects like SETI, Search for Extraterrestrial Intelligence, have focused on this, listening to thousands of stars hoping to catch that one signal that says, "We are not alone." Then there are laser emissions. Short, intense bursts of light in very specific wavelengths. A powerful laser beam sent deliberately across space might be used for communication or signaling. Such a burst, especially in the optical or infrared range, could travel enormous distances and still be detectable by our telescopes, provided we're looking in the right direction at the right time. A more speculative but fascinating category includes Dyson spheres, massive structures built around stars to harness their energy output. While we haven't found one, astronomers have searched for stars that suddenly dim or show unusual infrared signatures, which could suggest something artificial is collecting or redirecting the star's light. One such star, Tabby's star, captured attention in 2015 because of its strange and dramatic fluctuations in brightness, leading some to speculate about megastructures, though natural explanations like dust remain more likely. Another subtle technosignature is pollution. Just as Earth's industrial activity leaves traces of gases in our atmosphere, alien civilizations might inadvertently mark their planets with industrial byproducts. By analyzing the atmospheres of exoplanets for compounds like nitrogen dioxide or chlorofluorocarbons, CFCs, which don't occur naturally in large amounts, we could detect signs of industry, even if the civilization itself is long gone. Artificial satellites could also betray the presence of technology. If an exoplanet has unusual shadows moving across its star or irregularities in its transit light curve, it might be due to orbiting structures, spacecraft, or communication arrays. Finally, there's the concept of stellar engineering, modifying entire star systems for energy, habitability, or transportation purposes. While highly advanced and speculative, such projects could leave distinct fingerprints, symmetrical shapes in star emissions, unnatural heat signatures, or even stars disappearing from the sky, a potential result of being cloaked or harvested for energy. These different types of technosignatures give us multiple tools to investigate the galaxy. Even if we don't hear a direct message, the presence of technology leaves footprints, and in the vast cosmic wilderness, those might be easier to spot than life itself. While the universe has remained largely silent, a few signals have captured the attention and imagination of scientists and the public alike. These aren't Hollywood-style messages from aliens, but they are real anomalies, strange, unexplained blips in the data that made astronomers stop and wonder, could this be it? Let's start with the WOW signal, arguably the most famous mystery in SETI history. In 1977, astronomer Jerry Ehman was scanning radio data from Ohio State University's Big Ear telescope. Suddenly, a 72-second burst of strong, narrowband radio waves stood out, right at the frequency scientists expected an alien transmission might use. Ehman was so stunned, he scribbled "wow" next to it on the computer printout. Since then, no similar signal has ever been detected again, and efforts to trace its origin, whether a comet, a satellite, or something artificial, have all come up empty. It remains one of astronomy's great unsolved puzzles. Then there's FRBs, fast radio bursts. These are millisecond-long flashes of intense radio energy coming from distant galaxies. The first was discovered in 2007, and at first scientists thought it was just a glitch. But then more appeared, and some of them started repeating. One repeating source, FRB 121102, comes from a dwarf galaxy over 3 billion light-years away, and it keeps going off. We don't know what causes FRBs. They could be exotic objects like magnetars or something even stranger. Could they be artificial? Most scientists lean toward natural causes, but the mystery isn't solved. And what about Tabby's star? Officially named KIC 8462852, this star made headlines in 2015 when astronomers noticed it dimming erratically by as much as 22%. No other star behaved quite like it. Some speculated that a swarm of alien megastructures might be orbiting the star, blocking its light, like an unfinished Dyson swarm. While later studies suggested the dimming was likely due to dust clouds, Tabby's star remains one of the strangest stellar objects ever observed. Another curiosity, the Avi Loeb Oumuamua theory. In 2017, astronomers spotted an interstellar object named Oumuamua flying through our solar system. It had no visible tail, no outgassing like a comet, and its motion didn't entirely match gravitational expectations. Harvard professor Avi Loeb proposed it might be an artificial object, perhaps a thin light sail or probe. While most scientists argue for a natural origin, Oumuamua didn't behave like anything we've seen before. These cases don't prove the existence of extraterrestrial intelligence, but they do show that the cosmos is full of unexpected phenomena. Each strange signal adds to a growing library of what-ifs and reminds us that we've only just begun to understand what's out there. For all the listening, scanning, and theorizing we've done, one question still haunts the search for technosignatures. Why is the universe so silent? This unsettling question is at the heart of what's known as the Fermi paradox, a concept named after physicist Enrico Fermi, who famously asked in the 1950s, "Where is everybody?" Statistically, the galaxy should be teeming with life. There are over 100 billion stars in the Milky Way alone, many of them older than our sun. Many of those stars have planets, and some of those planets are likely Earth-like. If life is common, and if even a small fraction of it evolves into intelligent civilizations, some of those should have developed advanced technologies and spread across the stars. And yet, nothing. No signals, no probes, no evidence. Just silence. So where is everyone? Scientists have proposed several possible explanations, some optimistic, others quite dark. 1. We're not listening the right way. Maybe the signals are out there, but we're simply not detecting them. We've only been listening to the sky for a few decades, and with limited bandwidths, directions, and time. Imagine trying to catch a whisper across a vast stadium. If you're not listening at the right time and in the right direction, you'll miss it. It's possible aliens communicate using frequencies, formats, or technologies we don't yet understand, or even can understand. They might use quantum entanglement, neutrino beams, or dark matter manipulation, all of which are still speculative or inaccessible to us. 2. We're too early or too late. Maybe we're among the first civilizations to reach this level of development, or maybe we're too late, and other civilizations have already risen and fallen before we even emerge. Civilizations might have a short technological window, advancing rapidly but also self-destructing quickly through war, environmental collapse, or runaway artificial intelligence. We may simply be out of sync in cosmic time. 3. They're choosing silence. Some believe that intelligent civilizations deliberately remain quiet. This idea is called the dark forest hypothesis, a chilling concept suggesting that the universe is like a dark forest where everyone is hiding, afraid to make a sound. After all, if you shout out your existence, you might attract the attention of something dangerous. In this scenario, civilizations choose to go dark, cloaking their signals or masking their activity to avoid becoming targets. 4. We're not worth contacting. Yet what if we're being watched, but not contacted? Think of how we observe animals in nature. We study them, but we rarely interfere unless necessary. An advanced civilization may see us as primitive or unstable, choosing to observe quietly until we're ready, ethically, socially, or technologically, for contact. This idea is called the zoo hypothesis, and while unprovable, it raises deep philosophical questions about our place in the cosmic hierarchy. 5. They're already here, and we don't recognize them. Perhaps alien life is around us in forms we can't perceive, as non-biological intelligences or existing in higher dimensions beyond our senses. Or perhaps their artifacts are out there in our solar system or galaxy, but we've missed them entirely because we don't know what to look for. We may not yet possess the conceptual framework to even define what alien life truly is. As we gaze into the night sky, we are met not just with stars, but with a vast, unanswered question. Are we truly alone? For over half a century, humanity has listened, searched, and even reached out across the stars. We've crafted radio messages, launched golden records aboard Voyager, and scanned thousands of stars with powerful telescopes. And yet, silence. But silence doesn't mean emptiness. The universe is not obligated to be loud. It may whisper in frequencies we haven't tuned into, in signs we have not yet learned to read, or in forms we can't even imagine. Just because we haven't found technosignatures doesn't mean they aren't there. It might mean we're still infants in a galactic conversation that spans eons. Every unanswered signal, every wow moment, every strange blip in data reminds us that the search is far from over. Perhaps the real question isn't where is everyone, but are we even ready to understand the answer? In searching the stars, we are not just seeking others, we are learning about ourselves. Our curiosity, our reach, our hope, they drive us beyond the edges of what is known. So maybe, just maybe, the search is the answer. Because in the act of looking, we become something greater, a civilization that dreams beyond its world and listens, not because we expect to be answered, but because the silence is too profound to ignore. We are listeners, dreamers, explorers, and someday perhaps we'll no longer be alone.